Hello everyone, my name is Anyu Yu, an assistant professor in Zhejiang Gongshang University. I'm glad to share my research at here. My research topic is about the shared and unsplittable performance links in network DEA. Now I would like to talk about the background of this study. The research purpose of this paper is that, in many cases, shared inputs and outputs are not technically shared or not easily divisible among different components of network model. Thus, we need a new method to concern about the performance evaluation with unsplittable shared measures. To achieve this, we adopt two-stage network DEA models, where the shared and unsplittable performance measures are considered links between the two stages within the network structures. In this study, we propose a basic network DEA model, and the basic model is previously discussed in Chen 2009. We assume there are M inputs, S outputs, and D intermediate variables, and they have their corresponding weights. Based on the above settings, we aim to propose the conceptual structure of the network models with L unsplittable minimizing links or Q unsplittable maximizing links. Here, the minimizing links are regarded as the input to both stages, and the maximizing links are as the outputs. Both models with two-stage processes can be depicted as these figures in sequence. The aforementioned measures are based on the network DEA framework with intermediate link Z. Here we elaborate on a complementary case of the two-stage process without the intermediate links, but with unsplittable minimizing links. This is a special type of network model without a sequential relationship between two stages, and the shared and unsplittable links have become the only links between the two stages. The conceptual figures is depicted as follows. In the literature, there are two streaming methods for measuring the unsplittable links between network stages. The first is that, according to Cook 2006 and Cook and Zhu 2007, dual-role variables are intermediate factors that play both input and output roles simultaneously in the two-stage network DEA structures. The other type of dual-role variables is called feedback measures, which are outputs from the second stage that are fed back as inputs to the first stage. The possible improvement of our method is that our model endorses the integrality of the performance link, and no portions of the shared input are calculated and allocated to the two stages of the DEA model, and neither stage is assigned a portion to disaggregate the link between the two stages. The shared input is modeled as one link but not two nodes. We developed the framework based on a two-stage network DEA model involving one single shared unsplittable link, and we demonstrate the formulation for both the minimizing and the maximizing links. Now we can have section 2 methodology. Here we will introduce our model formulation. Due to the basic definition of the standard network DEA, we can define the performance scores of the first and second stages as these formulations. By combining both performance scores into the objective function, we can get the network model 3. In this model, alpha means predetermined importance weights for the first stage. Model 3 is a nonlinear model. Thus, we can conduct a transformation with the new parameter k to make a simplification. Then we can get the model 4. Note that Model 4 is a nonlinear model with unsplittable minimizing measures. We should use a heuristic search method proposed in Liang 2006 to transform it into a linear programming model. We try to vary the value of parameter k based on its feasible regions and try to get the global optimum. To achieve this, we propose Model 5 to define the value interval of k as this. Once we obtain the interval of k by solving a sequence of linear programming problems through varying k within the feasible region based on a fixed step length, we can compare all the optimal solutions and pick out the best one. The optimal solution in terms of the best k is our global optimal solution to the model. Similarly, we also proposed the corresponding model transformation and the heuristic search method to get the global optimum in a shared and unsplittable maximizing measure. We also propose a new model to get the feasible region of k. The main innovation of our method is to launch the model formulation of unsplittable measure and proposed a corresponding method to solve for the computation difficulty in the nonlinear programming. Now we go to our application section. In this section, we apply our developed model to a set of 100 banks in the United States. The data for these banks are collected from the Thomson Reuters database in 2017, and they include variables, total interest expense, total deposits, fixed assets, total loans, interest income and ROA, return on assets, and ROA's volatility. These variables are classified into 4 categories: inputs, outputs, intermediate measures, and the shared and unsplittable performance link. Figure 2 displays a two-stage network structure with a shared and unsplittable minimizing link using the bank's data. Based on the acquired data, the stage performance of loan efficiency and profit efficiency are derived from Model 4. Note that we set alpha at 0.5 to treat both stages of the network equally. The summary of result is presented in Table 1. The DEA results show that the mean efficiency of the profit generation is higher than that of loan generation, implying that these banks perform better in making money from loans than they generate loans from deposits. The standard deviation of profit generation is also very small, less than 0.1, indicating that these banks generally perform well in profit generation and there is not much variation in their performances in profit generation. We also measure the performance scores of each stage independently as two separate processes by Model 1 and 2. Table 2 shows that when the two stages are evaluated separately, banks' average performance in profit generation is still better than their average performance in loan generation. The 100 banks were grouped according to their consolidated assets and the DEA results of the first 10 banks with the highest ranked consolidated assets are as follows. Table 3 shows these banks' individual sub-stage performance scores by using Model 1 and 2, while Table 4 shows the Model 3's results. The difference between Table 3 and Table 4 results is that in Table 4, performance scores are calculated by treating ROA's volatility as a shared and unsplittable minimizing link. To the contrary, in Table 3, performance scores are calculated for the two standard DEA models and always volatility is treated in both stages as a normal shared input. Remarkably, the shared and unsplittable link makes an impact on the substage performance scores. The performance of all 10 companies with highest consolidated assets are reduced when always volatility is treated as a shared and unsplittable link. To investigate whether the results would manifest different characteristics with different values of alpha, we perform a sensitivity analysis as presented in Table 5. The corresponding efficiency scores with different levels of alpha are obtained. In Table 5, it can be observed that as the value of alpha increases, the overall efficiency and the profit efficiency decrease, while loan efficiency increases. Subsequently, we discover profit efficiency has a more dominant impact on the overall efficiency because the overall efficiency score decreases when the importance of profit efficiency in the objective function is reduced. Now we can get the conclusion. We have used the bank case to demonstrate the effectiveness of our proposed method. The current paper develops a two-stage network DEA model that with shared inputs that cannot simply be divided among or allocated to each stage according to a set of predefined weights. The distinction of our model from extant DEA models dealing with shared performance measures is that no weights are designated for the individual stages, and the link remains integral. To address the nonlinearity of the resulting network DEA model, a parametric linear algorithm is adopted. That's all for my presentation. Thanks for your attention.